This is a little fun project that we've been working on called the JDation OctoPI Mashup, and it's really a physical device that sits next to your 3D printer that allows you to have a touch screen that allows you to start, stop jobs, but also incorporates some physical buttons that allow you to actually control the printer very easily. Here you can see me using the buttons to toggle the bed around in the head left and right. It's really come in handy for quick things you want to do when you're just trying to clean the bed or things like that. You can easily quickly get the head out of the way. This project uses actually several different kind of open source projects that are out there. The big component of it is the JDation design software, which is what we've used to create this enclosure here. It's also using a number of Octoprint plugins to map the physical buttons and the touch screen and those things. We're going to start this video off with a 1-minute assembly overview to kind of give you a quick overview of how the assembly process works, and then we've got a full 30-minute overview that really details out every single one of the processes we did to build this JDation OctoPI. Okay, this is the JDation OctoPI design. This is the first design that we've had, JDation 3D Tower. You can come through and see information, some pictures, of how this would ultimately come out. Including that, you've got the ability to do assembly instructions, shopping list. I'll show you all this in a second. You can obviously download this design in a number of different formats, and then of course edit, which we're going to come back to. The design shopping list, these are the things that you'll need to build this enclosure. We've got all of the different components that are being used, the different kind of parts, where you can go to purchase these things. Some variations. This is a blank one. It just allows you to start from scratch. And then some very high-level assembly instructions for this. So let me go back to this design. This was the prototype design, but then there was a few things that I think I want to make, some changes that I want to make to this, just to kind of show you how that works. So I'm going to go in here to the designer, and I'm going to edit this design. So this is the design, the JDation designer. In the middle here, you've got the design itself. You can see the assembly instructions here, and then you can see like this top panel here is this top section here, this back panel here, is this back panel here, and this bottom panel is here. And so what you can see we've done is on here, we've laid out how we want our top panel to look with the right buttons and a screen. On the bottom panel, we're going to mount an Arduino, or I'm sorry, Raspberry Pi, and on the back, we've got some input devices. So the way the designer works is over here on the left, you've got the ability, you can kind of zoom in, zoom out, the ability to insert electronics. We're going to come back to that in a second. Insert a cut hole. So over here, you can just do, whoop, there's a nice little round hole, and resize that. Square hole. Then you come down here to text decorations. So things like all this blue, this here vinyl decorations. And I'll show off some of these things here in a second. Got rulers, you can change the material colors, lots of things you can do over here. So what I want to do on this is I want to make a few changes to this. I want to change out some of these buttons to be square LED buttons. I figure I might add a little bit of decoration to the back. I don't know if I'm going to do that or not. But let's make a few tweaks to this thing. And again, you'd be able to make the same exact tweaks to this. Let's go over here. And this is the button that I want to use. It's Adafruit 16 panel mount button. So I'm going to insert that into the design, and you can see this one is a square button. So I'm going to put that where I want it. And then I'm going to duplicate that and create another one up here. And let's get all of these lined up. So that looks pretty good. Let's go ahead and make a few adjustments here. I feel like some of these things are a little off. Actually, no, I think it's better the way it was. Maybe we'll add a little text to the inside. I don't know that I'll actually apply this final label, but let's do it for the fun of it. Let's make it smaller. Yeah. All right, I think I can live with that. That's, again, I don't know that I'm going to add the stickers for this stuff right now. But I might come back and do this later. Now we are back, and you can see changes we've made are showing up on the main here. So now I want to go ahead and download the files I need. So there's two sets of files I'm going to need because I'm doing vinyl labels. I need to download the vinyl labels as an SVG. And then I need to download them as an STL for 3D printing. Okay, when you download and unzip the STL files, you will find 5 files in this design. The main body, which I'm just going to go ahead and quickly open up in Cura here. And you can see this is the main component, just like the assembly instructions. So this is the first thing you're going to get in the zip. And then there are the 3 panels. I'm going to just open each one of those up as well. This is the back panel. And you can see it looks exactly like it looked in the designer. This is the bottom panel. And you can see where the system has created these standoffs for you to mount the Raspberry Pi to. And then this is the front plate. And we're actually looking at the back of the front plate. And so this is the standoffs for the screen, and then all of our buttons, momentary switches, the holes for those in here. And then the only thing I'd show you, there's also and actually I just leave it here. There are these little straps. Move that up. And I need to lay it flat. And so you'll need 4 of these little straps. These little straps connect to this right here. And hold the, this little slot here goes right on there, and it holds the screen in place. So I'm going to go ahead and I'm going to make 3 more of those on my bed here, and then I'm going to go ahead and slice and print all these. So as we saw when we were in the designer, there was a lot of like blue areas which we called decorations, and those decorations ultimately turn into a vinyl label. And here I'm showing how you actually cut out and apply the vinyl label to your 3D printed design. And the first thing to do is to take your vinyl label and apply it to the cut sheet of your vinyl cutting machine. I am not an expert at any means in vinyl label cutting and application, so if you see something I could be doing better or easier, why don't you go ahead and give me some suggestions in the comments below. I have a Silhouette machine, so I'm using Silhouette Studio here, and I have just imported the SVG that I downloaded off the JDation website. Now, one thing we're going to have to do here is rescale our design because it doesn't scale in to at least Silhouette the right size. But what you can see is on every one of these designs, you can see the dimensions, 5.26 inches. It shows you what it should be. And so you just have to scale it to be those exact dimensions in Silhouette, and then it will work perfectly. So I've got it about the right size now. I'm going to slide it over. I think that looks good. So now we're going to go ahead and send it to the printer. So in JDation Designs, it's color based. So the cut lines will be it's kind of a yellowish color. You can see right here at the bottom. So I need to come over here to colors and deselect everything except yellow and send it to the Silhouette machine.
What? Is the stars actually here? Is it Daniel?
So now we begin the process known as weeding your vinyl. And this is definitely an art form. I am not great at it, but actually, if I can do it, anybody can do it. It's pretty straightforward. So the first thing we have to do here is we're just going to peel off basically the unused vinyl, the vinyl that's not going to get applied. So you just got to go very slowly, and if something starts peeling up that shouldn't be peeling up, like you just want the actual parts of the vinyl that are going to get applied to stick to the white part. And so if something starts coming up, you can just get an X-Acto knife or something and kind of push it back down. So just kind of go slow as you're weeding, and it will be fine. Next, I'm going to pull out the inner cut section. So this is obviously where it's going to be the outline for the screen. And then I got to go back through, and there's some little cuts in the middle of some of the letters and some of the images and things like that, and you got to remove that as well. So now we need to apply transfer tape so that we can get the vinyl label off of its backing. This is the more tricky part of vinyl, in my opinion, is the transfer tape and then actually applying it to the 3D printed part. I'm really trying to smush all the little pieces of vinyl really well into the transfer tapes, or so that when you pull back this transfer tape, it will peel off the vinyl and leave the backing. Go nice and slow, and if anything doesn't peel off, you can just see right there. I just kind of let it back down and pushed harder on the vinyl to make sure it sticks really well to the transfer tape. And now the very tricky and nerve-wracking part of actually applying it to our 3D printed part. So now we want to really make sure that the vinyl is now stuck really well to the 3D printed part. So when we pull off the transfer tape, the vinyl will stick to the 3D part and not the transfer tape. And again, if anything starts peeling off of the transfer tape, just pause and kind of push the vinyl back down onto the 3D printed part and continue on. There's tons of videos on YouTube on how to do vinyl work. This is a very popular hobby. Turned out really well. I like it. So now it is time for some assembly. And the first thing we are going to do is insert all of our buttons or momentary switches into the hole of the front plate that we 3D printed and applied our vinyl labels to. So this Adafruit touchscreen is designed to attach directly as a shield to the Raspberry Pi, but that's not going to work for us. So I needed to create basically an extension cord between the screen and the Raspberry Pi. So I did some prototyping here to figure out how the wires, which wires were necessary to create this extension. And I also bought this little elbow thing that I thought would make it easier to kind of assemble and disassemble the Raspberry Pi work. So I just did this real quick and dirty to figure out the wires. And now here I'm going to go back and actually try to do this the right way and apply some of these little DuPont connectors and make sure I can reassemble this thing and it still continue to work. So this is the final extension cord, if you will, with the little elbow connector attached to the Raspberry Pi. So now we are going to insert the touchscreen into the front plate. Kind of snaps into a little square holder that keeps it from sliding left or right. And then there are these little straps that you screw down that hold it in place very well. So I got this Raspberry Pi header breakout board that I thought would make it easier to assemble this. To be frank, I'm not sure it did make it easier. It felt like all the wires really got cramped together. So I'm not sure that I would recommend using one of these little breakout boards for what I'm trying to do here, but it might be the best way. Maybe paste some comments in about how you would do the wiring of this. One other thing I would mention here is I actually ended up wiring this wrong, and so what's not shown in this video is where I actually have to come back and correct all my wiring because I did it wrong. So I have left that out of the video, but if you are trying to follow along and you're sitting here looking at this going, Jason, you're wiring this incorrectly, you are correct. So now I am setting up the back plate, And for this design, all I really am going to add here is I'm adding a USB extension cable. This is where I will power the Raspberry Pi from, so this is just a nice clean way to have a nice professional looking port on the back of your Jadiation 3D tower, and you just plug the power straight into this, and then obviously you'll plug this little pigtail into the Raspberry Pi to provide it power. And now for the really fun part where we assemble everything together. So the first thing we are going to do here is attach the Raspberry Pi to the base plate. And by the way, all of the screws that you need, these plastic self-threading screws, they're in the Jadiation design in the parts list. So you go there and it points you to exactly where you can go to get the exact screws that I'm using here. It's best to assemble the front plate in first. I think that just makes everything a little bit easier. You can hear my wife in the background getting some juicy details from one of her friends apparently. I'm going to plug in this pigtail before you screw the bottom plate on, otherwise it will be nearly impossible to get that pigtail in. And then we need to put the feet on. The feet are just these little rubber feet again. These feet are on the Jadiation website in the shopping list, and with a link to where you can go get these. The little the screw goes through the rubber foot and into the plastic. And then we just want to install the back plate the same way. It snaps right into place and is held in with 4 little screws. And there it is. It is fully assembled. I think it turned out really, really nice. I like this design a lot. So now that we have the enclosure all assembled, I wanted to show the software that we are using, some of the plugins in Octoprint. There's really 3 plugins that we are using. The first one is called OctoBuddy. You can see it right here. And what this allows you to do is assign the physical buttons to GPIO board pins, which then allows you to move the print head up and down, move the bed itself forwards, backwards, left, and right. You can see the mappings I have here for X, Y. There's actually a home button as well, which I didn't use. Something might be interesting for someone else to try. This is how you set the nozzle temperatures for pre-warming. OctoBuddy installation instructions are available on its extension plugin. Then we've got OctoDash here. This is what controls the touchscreen. It's got a very simple installation actually. There's not a lot of settings you actually set here. It's all kind of done via the installation script, and there's details there. on their website as well. And then this is actually a plugin that I created. It's very simple, basic plugin that just allows you to control when the heat bed turns on or the hot end turns on. It allows you to set the GPIO pin, and that's what actually turns the LEDs on the buttons on. So the light up buttons themselves, this heat plugin, heat LED plugin is what does that. So these are the three plugins that we're using to make all of the physical buttons and LEDs and touch screens work. It's actually pretty straightforward installation for all three of these. So that finalizes our build. I actually think this turned out really, really nice. I really like the looks of it. I think the actual physical buttons are extremely functional, and I've really enjoyed having those for my 3D printer. There are links in the description to all of the various parts of this build, and would love to get your feedback on some things that we can do differently to make this project even better. And I would encourage you to go and check out the JDation website. There's a lot of opportunities with the design software to create totally different custom enclosures, not just for the Octoprint software, but for any kind of electronics enclosure that you're using. It's really cool software.